A calcite sea is one in which low magnesium calcite is the primary inorganic marine calcium carbonate precipitate. An aragonite sea is the alternate seawater chemistry in which aragonite and high magnesium calcite are the primary inorganic carbonate precipitates. The early Paleozoic and the Middle to late Mesozoic oceans were predominantly calcite seas, whereas the Middle Paleozoic through the early Mesozoic and the Cenozoic, including today, are characterized by aragonite seas. Wilkinson et al., 1985, Wilkinson and Given, 1986, Morse and Mackenzie, 1990, Lowenstein et al., 2001, Palmer and Wilson, 2004. The most significant geological and biological effects of calcite sea conditions include rapid and widespread formation of carbonate hard grounds. Palmer, 1982, Palmer et al., 1988, Wilson and Palmer, 1992, calcitic oids, Sandberg, 1983, Wilkinson et al., 1985, calcite cements, Wilkinson and Given, 1986, and the contemporaneous dissolution of aragonite shells in shallow warm seas, Churns and Wright, 2000, Palmer and Wilson, 2004. Hard grounds were very common, for example, in the calcite seas of the Ordovician and Jurassic, but virtually absent from the aragonite seas of the Permian. Palmer, 1982. Fossils of invertebrate organisms found in calcite sea deposits are usually dominated by either thick calcite shells and skeletons. Wilkinson, 1979, Stanley and Hardy, 1998, 1999, Porter, 2007, were infaunal and or had thick periostrata. Poggiata, 1971, or had an inner shell of aragonite and an outer shell of calcite. Harper et al., 1997. This was apparently because aragonite dissolved quickly on the seafloor and had to be either avoided or protected as a biomineral. Palmer and Wilson, 2004. Calcite seas were coincident with times of rapid seafloor spreading and global greenhouse climate conditions. Stanley and Hardy, 1999. Seafloor spreading centers cycle seawater through hydrothermal vents, reducing the ratio of magnesium to calcium in the seawater through metamorphism of calcium-rich minerals in basalt to magnesium-rich clays. Wilkinson and Given, 1986, Lowenstein et al., 2001. This reduction in the Mg/Ca ratio favors the precipitation of calcite over aragonite. Increased seafloor spreading also means increased volcanism and elevated levels of carbon dioxide in the atmosphere and oceans. This may also have an effect on which polymorph of calcium carbonate is precipitated. Lowenstein et al., 2001. Further, high calcium concentrations of seawater favor the burial of CaCO3, thereby removing alkalinity from the ocean, lowering seawater pH and reducing its acid/base buffering.